get started. Okay, I am Evan Coury. I'm going to be talking to you about modules in Zend Framework 2. And my clicker's not working. There it goes. You might know me online. My nickname is evan.pro, everywhere on IRC, GitHub. I'm a Zend certified engineer. I'm the author of the module manager component in Zend Framework 2. So that's why I like talking about this subject. I'm pretty passionate about building applications in a modular way, so this is a topic that's pretty important to me. So what is a module? A module is a reusable piece of functionality that can be used to construct a more complex application. So what does that mean exactly? It means you write your code once. So instead of writing user authentication into every application that you build, you can just write it once as a module. And then you can just install your user authentication module in all your applications. You don't have to keep reinventing the wheel every time you build an application. So modules in Zend Framework 1 kind of sucked. How many people in here used Zend Framework 1? I know at least 2 in the front, so cool. Okay, so pretty much everybody in here. So modules in Zend Framework 1 had limited support for reusability. You couldn't really create a module that could be used in more than one application in a clean way. And that was evident because you can't really go around the internet and find like cool Zend Framework 1 modules to install. They just don't exist. There's nothing like that out there. And there's also no packaging mechanism for modules in Zend Framework 1. There's no clean way to just like install a module, drop it in, and have it work. There's no distribution mechanism, really. We have Composer now. That wasn't as prominent back when Zend Framework 1 was around, and we didn't really structure modules to take things like Composer into account. Probably the worst part about modules in Zend Framework 1 was that they were coupled with the MVC. So what a module was in Zend Framework 1 was kind of predetermined by the framework. It said, okay, a module can provide some controllers. They have to have this class name. They have to follow these rules, and that's pretty much all a module can be. And that is not a very powerful way to handle modules because they're inherently limited. Now, bootstrapping in Zend Framework 1. That's a pretty bad subject as far as performance goes. The bootstrapping is very excessive. Everybody in here pretty much raised their hand when I asked if you use Zend Framework 1, so you're probably familiar with the underscore init methods in your bootstrap classes. Those all run every single time. It doesn't matter if you need those resources or not. Zend Framework 1 is just going to initialize them for you. It doesn't really care. So that was not the most efficient way to handle bootstrapping. So we took all these problems and we tried to solve them. In Zend Framework 2, we made modules reusable. They are very simple to just drop in, and you have gained all this functionality in your application. They're just a folder. There's nothing else that you need to put anywhere else. It's really, really simple. We support Phar packaging, so you can even zip up your module into a single file, send it to somebody. They can just drop the Phar file or the zip file right into their module directory, and it'll just work. It'll run right out of the archive. You don't have to even extract it, which is pretty neat. Now, the usefulness of that, we have Composer now, so it kind of accomplishes the same thing. Back when this was actually being developed and I was adding the Phar support, it was a lot cooler because Composer wasn't as prominent as it was now. So either way, with Zend Framework 2, it's very easy to acquire and install modules. They're also lightweight and very fast. So if you install a bunch of modules, your site's not going to start slowing down. It's not loading a bunch of new stuff every time you add a module. It depends on how it's written, but typically the services that a module provides, the classes, the resources, are not loaded unless they're actually used. So once you go to use that resource or that database adapter, that's when it's going to be created. And that makes it much faster to actually bootstrap your modules. So what exactly is a module, or what can it be? Modules can be pretty much anything. Like I was saying, we didn't limit what a module could be. We didn't put any definition of a module inside the framework. So you can pretty much do anything you can dream up inside of a module. You can create plugins for an existing system, e-commerce platform. You can add Markdown support for an existing blog, something like that. So it works as a plugin system for whatever application you're building. You don't have to build your own plugin system. Themes, so you can provide your CSS and images and view scripts that you need for your application as a theme. You can bundle all that up as one module and just have a module that you install that changes the entire look of your website. It's that easy. You don't need to build a theming engine in Zend Framework 2 because the module platform works for themes. It's just done. Libraries. So if you're writing a library, don't write it as a Zend Framework 2 module. That's not exactly what that means. It means that you can write a module that integrates an existing library with Zend Framework 2. So you can write modules that act as a bridge. If you're writing a library, just write it as a library. That's what it should be. There's actually already Doctrine 2 integration. The Doctrine project actually maintains their own Doctrine module for Zend Framework 2, and it's actually really good. It provides all sorts of integration with authentication adapters and form validators for DB record exists or not exist. And then the coolest part is when you put all this together. So you can build all these modules and construct an entire application. So you can build an entire e-commerce platform that's built of a bunch of modules. And this is kind of what that would look like. I have a client for my company that we're building an open source e-commerce platform for in Zend Framework 2. And these are just some of the modules that compose the e-commerce platform. Not all of them. I think we're up to like 35 or something now. But this is kind of to give you an idea of how you can combine modules to create a more cohesive application. So we have this module called ZFC user, and that is what I described in the beginning. You can just drop ZFC user in, and you've got user authentication, you've got registration, everything that you need, and it follows all sorts of best practices, so you don't have to worry about that. And I'll talk about that in a minute. But the cool thing is how you can combine really simple modules to create a larger experience. So we have spec address. And spec address is a module that simply provides the concept of addresses, a service for adding addresses or fetching addresses from a database. It provides a schema and a database mapper for addresses. But then we have spec user address. Spec user address is another module that almost glues ZFC user and spec address together. And what it does is it gives the concept of a user having an address. And it's that simple. So then you, at that point, have address books for your users. But I can use that module in any application that I need that has addresses. It doesn't have to be an address that belongs to a user, just an address, and it'll work. And we kind of followed that same mentality as we kept building this. And so a lot of spec commerce, you can just pick and choose some modules that you might need for your site, and your site might have nothing to do with e-commerce at all. So ZFC user is another great example. It's drop-in, and it just works. It applies a bunch of best practices like I was talking about, so you don't have to worry about that kind of stuff. Out of the box, it's going to use bcrypt and slow hashing. It also works with ZendDB by default, but there's also support for Doctrine, MongoDB, pretty much any backend. Somebody was just doing an LDAP plugin for it, and it's extremely extensible. And you can tell because of all the third-party modules that have popped up that add new functionality to ZFC user. SCN social auth is my favorite. You can install ZFC user and then add SCN social auth, and all you have to do is go into the config file and add your Facebook API key, Google API key, whatever social site you want, and now your users can log in with any of those sites, and it just works. It's probably 3 minutes to get all of that running, whereas before something like that would be a pretty large project. Okay, so this is the directory structure. Has any of you guys downloaded and tried out the skeleton application for Zend Framework 2? Raise your hand. Okay, so about half. This is the directory structure that you'll see when you download the skeleton. One thing to keep in mind is that the directory structures in Zend Framework 1, they were kind of determined by the framework. Like we had the resource autoloader that kind of defined what the module, or what the path names had to be, and they were like lowercase plural, which was terrible. But that's not true anymore in Zend Framework 2. So all these paths and directory names are actually defined in userland. The index.php actually just references where this application config is. The application config references where it's going to load the modules from. And we'll actually go through that. But all the paths are actually defined by you in your code, not the framework. So it's a key difference. So the config directory is the place where a lot of your configuration is going to happen. It's the only place that configuration happens outside of modules. The rest of the configuration is provided by modules, which we'll talk about. Application config is special. This is the configuration that is loaded before anything else. It's not merged with anything else. It's its own standalone configuration. And in that is where you're going to define what modules are actually loaded and where they're loaded from. And we'll take a look at the contents of that. The data directory. So as a best practice, your modules should not write within themselves. So you shouldn't have any kind of mutable directories, log files, or anything like that in the modules. Put that at your application level out here. And everything should write within that. So if you have a module that's writing logs, maybe have it create a folder underneath data with the module name or something like that. Don't write within the actual module. So then we have the module directory. That's where your application-specific modules will go. You might install, spec address or ZFC user. Those are going to go under vendor. And it's just a matter of organization. This is a recommendation. You can put any module under either of these two folders, and it's just going to work. Just as a best practice, it's better to separate them this way. Also, if you're using Composer, Composer by default puts everything under a vendor directory. So this way it works nicely with Composer. Everybody's familiar with a public directory. That's where some of your base application-wide assets are going to go. So this is, if we actually go into this application module here, this is right here. This is what you're going to see when you actually go into an application. This is where you're going to spend most of your time. Like I said, everything's in modules. You're not going to have anything at an application layer and then in modules. In Zend Framework 1, it was kind of vague. You could have, your application just as the application, but then you could also use the module autoloader, and it would kind of go nest it one directory in. You could have a default namespace for your whatever your default module is. It's not like that anymore. It's just everything's a module. By default, you can just put everything in your application module if you're not trying to break it up into modules. I don't recommend that. You should probably think of ways to split up your application. So underneath the module directory, we have a config directory. And in there, we have a module.config.php. In there is where you're going to define any kind of default configuration for your module. It's just going to be an array, and you're going to return it out of that file. And we'll actually take a look at how that works. And then we have this SRC directory. The SRC directory is where any classes are going to go, your PHP classes. And underneath here is PSR0 compliant. By show of hands, how many people know what PSR0 is? Okay, just a couple. PSR0 is a standard for autoloading. And what it states is that there should be a one-to-one relationship of the class name and the namespace to the actual class. So right here, you're going to have a namespace for application, subnamespace controller, and then the class name is going to be index controller. In Zend Framework 1, we had underscores, not namespaces, but it kind of worked the same way. There just wasn't actually a standard that we were following. Now it's actually a standard, and everything under SRC should follow that standard. So if you're trying to find a class, you can go under SRC and you know exactly how to find it. Then the view directory. View directory actually works exactly the same as Zend Framework 1. And I think everybody raised their hand when I asked how many people use Zend Framework 1. But it's just a one-to-one mapping, except for lowercase, of your namespace for your module, the controller, and then the action name, .html. Then we have this module.php file down here, and we'll talk about that. That's the most important part of any module. So this is that application.config.php that I was talking about. That is the first configuration that's loaded at all by the framework. And this is where you're actually going to define which modules are being loaded. So in this case, we're loading 3 modules. And we're telling it here with this module paths array, these are the places that we want it to look for those modules. And it works just like the PHP include path. And then you can also specify exact paths to find specific modules using an array key in the module paths. A big question I always get is how to toggle which modules are loaded based on the environment that you're in. And it's really simple because your config file for defining your modules is just a PHP file. So do whatever you want to actually perform that logic. In this case, we're getting the environment variable app environment and defaulting it to production. We're creating an array here with the application module, but if the environment is development, we're adding Zend developer tools. It's that simple. Then when we go to return our array, we just say modules is this $modules variable. So the module paths, it works just like the PHP include path. Like I was saying, it's trying to find the application module. It's just going to go through that list of directories until it finds one. It's the first one it finds, that's going to be it. So if you have the same module in multiple paths, it's going to find the first one. We have pretty much the best Phar support of any project that I've seen. And it's pretty neat. We support all the different file extensions that Phar supports. And if you're not familiar with Phar, Phar is, it's like the jar of PHP. Or I've heard one person call it the EXE of PHP. I don't like that analogy at all. But it's basically you can take a whole directory of code and everything that is required to make that code run, make it one file, and distribute that file, and people can just run that. So to actually package a module up as a Phar, it's really easy. You can just tar it, the whole directory as a tar file. On Windows, you could right-click, make it a zip file, and you're done. It'll actually just keep running. It'll just work. And that's pretty cool. Do not do this. I put that there to show the simplicity, but don't actually use a compressed format. So don't use zip, don't use tar.gz. It's just a waste of CPU to sit there and have it decompress the file every time that a request comes in. If it's a non-compressed format, it doesn't really add any overhead at all. In fact, it might actually be less I/O operations because it just loads one big file and it's all in RAM. So I haven't actually benchmarked that, but it doesn't hurt performance at all. And Phar packaging is completely transparent. So you don't have to change anything in your module to make it work, though there are 2 exceptions. Modules should remain intact from their upstream distribution, or your case, you are the author, then just what that basically means is don't hack the module. For a third-party module, don't hack it. Don't try to go in and change the code and stuff, because you want to be able to update that and pull down the latest changes without it being a problem. And we've made it really easy for you to replace the parts of modules that you need to externally without actually touching their code. So do that. Also, don't perform writes within your modules like I was talking about earlier. So in your own modules, don't be writing into a data directory inside the module, because if you actually Phar up or package your module, it's not going to work because you can't write within that Phar file. And then there's no real path or glob support. That's just a PHP bug, and it probably will never be fixed. It's been open forever. Just as long as you don't use those, you're fine. I've been fine using relative paths, and it's never been a problem. And I haven't heard of anybody so far in over a year that has run into this, so I don't think it's a real problem. Just something to be aware of. So I've been talking about these file extensions. These are all the file extensions, the actual Phar formats that PHP supports, and Zend Framework 2 by default will load any of these. So if you have your module in the module directory that's packaged up in any of these formats, it'll just work. You don't have to do anything special. Do not use the compressed formats. Avoid all of them. Any of these non-compressed, so tar, if it ends in tar, or Phar, those are fine. Pretty much only those. So, yeah, there's no reason to use compression there. And module distribution. This is my favorite part because this is the part that builds a community. We have Composer and Packages now, and we have a bunch of other ways that you can actually install modules as well, in addition to Composer and Packagist. And Pyrus is like Pear 2.0. It's like the new version of Pear. You can put your modules up on a Pyrus channel if you want. You can also just clone straight from GitHub, and everything will just work fine. Or you could just download a Phar file from somebody's website. And you can also just always drag and drop the modules right into your application. We have a website now, modules.zendframework.com, that the community's put together. And if you go out and write your own modules, you can go to this website, just click sign in at the top. It's going to sign you in with your GitHub account, and you can just add your modules. Just put them up on GitHub, and then you can add them right to this site. Right now, there's actually no moderation queue or anything like that. You publish your module, it's going to go up live. That's just because we haven't been spammed yet, so as long as we're not spammed, that's going to be the way that it is. Check before writing your modules. Don't just go and write a module because you need one. Go look for it. Probably already exists if you're doing something that's fairly common. So don't just be like, oh, I need a module, I'm going to write it. Or go look for a module and then you're like, oh, this one's not exactly what I want, so I'm going to write a new one that's better. Contact the author and say, hey, this doesn't work for our use case. What can we do about making it better? And try to improve the existing modules. It just hurts the community when you're trying to find a user module and there's 14 of them and they just vary in small little things, and you're like, oh crap, now I got to look who's maintaining it better, who wrote the better test, and you have to worry about all that because there's 14 versions of the same damn module. So try to avoid that. Don't contribute to the problem. Try to work with existing authors, and at minimum just make a branch of theirs, and whether or not they accept that back as a pull request is up to them, but at least you're not having to start from scratch. If you do find yourself having to write a new module, consider open sourcing it. A lot of companies love to think that their applications are completely proprietary. However, in practice, of all my clients that I've ever had, usually only about 5% of their actual application contains anything even remotely close to being proprietary. So, you have user authentication. If you're some stock trading software company, your user authentication has nothing to do with any proprietary part of your business. If you have any kind of user settings management or something like that, that's not proprietary. So consider making general purpose modules as much as you can and open source those and help the community. And then, your remaining 5% of your application that is proprietary, that's fine. Now you have very low overhead of actual proprietary code that you need to maintain. The rest is open source. If you're writing good code, the community is pretty strong. There will be people that might come in and help contribute to your modules. So, also, there's open source code does not write itself. The reason that we have such a strong community is because people are going out there writing their code, putting it up on GitHub, and not just keeping everything, closed. And that's why Symfony has a great community for that as well. And they've been pushing for a lot of companies to write open source modules instead of keeping everything proprietary. All right, so we're going to walk through real quick the steps involved in creating a Zend Framework 2 module. First step, you got to think of a name. Actually, that's not the first step. What did I say the first step you should do before you create a module is? Does anybody remember? You should go look for it. Probably already exists. So go check for existing modules first. Then you can go to step 1. Think of a name. Naming your modules, it's pretty simple. It follows the same rules as PHP namespaces because your module essentially is a namespace. So it can't start with a number, can't have dashes, can't have dots, kind of like variables also in PHP. And then also use a prefix. So like I use the prefix EDP for Evan.pro. I would call this EDP Markdown, not Markdown module, nothing generic. You end up with module names out in the community like Markdown module, Uber Markdown module, super cool Markdown module, and that just doesn't help anybody. At least if you have some kind of a prefix that you can kind of associate with somebody or a group of people that are maintaining that module, it's easier to kind of go through the modules and it helps the community. The next step is to create a directory with that name. Fairly simple. and then create a module.php file. That's that special file I was telling you about earlier. That's the key to Zend Framework 2 modules. And this is what it actually looks like. That's a fully functional Zend Framework 2 module that does absolutely nothing. It's the most useless Zend Framework 2 module, but you can load that and it'll work. So all you have to do is define a namespace that matches your module name, that is your module name, and define a class called module. That's it. It's the only thing Zend Framework is going to look for in your module. It's not going to look for any other files, any other directories, or anything. This is it. This is how you communicate with the framework. So there are no other requirements for a module besides that file. This is actually a fully functional module now. This is the entire module. It's EDP Markdown, that module name I was talking about. And in this case, I've actually kind of hacked the concept of this module class by making the module class itself a view helper. It's just extending the abstract view helper class. I'm not going to necessarily say that's best practice, but it's really cool and it fits on a slide. So it works in this case. And all it does is it has this function get view helper config. And there are a few functions like this, we'll talk about them, that the framework will actually look for to see if you've defined in your module class. And it'll take the return value and it will register, in this case, it registers a view helper called Markdown, and it's registering the instance of this as that view helper. And then you have the invoke string, which is using the PHP Markdown library to actually render out the Markdown. And this is what it might look like. You just, in your view script, call this Markdown, and that's it. Equivalent modules in Symfony, they call them bundles, and Cake PHP, I was looking at a few of them. They're like 40 files, a bunch of folders, all this stuff. That's it. That's a full working module in Zend Framework 2, because we don't have a lot of requirements for a module to actually work. And you can actually use this. This is up on GitHub if you need to add Markdown to your application. So we'll actually talk about the module manager component. It's a flexible and really powerful system for just loading components of code or really anything that you need to load into your application. So it was built to be generic, not just for Zend Framework 2 modules. You might have a project that isn't really based on Zend Framework 2, but you need some concept of plugins or something like that. You could use the module manager for that. It works pretty well. There are other frameworks out there. PPI2 is another framework. It's actually using Zend Module Manager to load its modules. And that's quite interesting because PPI2 uses a lot of Symfony components. So it's meant to be very general purpose, and it's not complicated internally. So let's talk about how it actually works to load modules. So it uses events. So it really, as it's going through and loading your modules, all it's doing is firing a sequence of events. The actual code is all in listeners to those events. So if you were to go through the module manager, you'd be like, I don't see it actually doing anything. It's just trigger, trigger, trigger. And there's a reason for that. That allows you to customize what actually happens as modules are being loaded if you want to. You can do that from within the first module that gets loaded. So we have this load modules event, and it basically loops through each module name that you have defined and calls these other events, load module.resolve, load module, and then there's finally a load modules.post. So the load modules event is really used internally. This is the one you can't actually attach to. I probably should actually remove this slide because it's already been fired by the time your modules get loaded, so you can't do much. It's just used internally by the framework to attach the module autoloader, which is capable of finding your module.php file, but that's all it's used for. Then we have the load module.resolve event internally. And this is what takes the string that is your module name and actually turns it into an object, an instance of it. And it's really, really simple. This is basically taken out of the framework, so you can see what it's actually doing internally. It has a method that basically says the module name is, it pulls the module name out of the event. That's the string that was in that array. Just returns a new instance of module name / module. That's all it does. The cool thing is, since that's a listener, you could attach your own listener in that place. If you don't like the class name module and you want to load something called bundle or whatever you want to do. If you want to add extra behavior before a module class is actually initialized, you can do that because this is just a listener. And this is how it's actually attached to the event manager internally. So then we have the load module event. This happens after it's been resolved to an actual object and we have the instance of your module class. And this has a bunch of listeners attached by default that do a bunch of things. Those different methods in the module class that I was talking about, the get view helper config, there's some other ones. It's these listeners that are looking for those methods to see if your module class has those methods. So the load module event is fired and it starts going through each of these listeners is triggered for each module. The AutoloaderListener, it's looking for a getAutoloaderConfig method. That's probably the most important one. So that src directory where all your PHP classes were, in this method in your module class, you're going to tell Zend Framework, hey, I've got these classes with these namespaces. You can find them in this folder. And that's how Zend Framework is actually going to know where to find your classes. And basically, if you need to know the array format, it's the same format that's passed to the autoloader factory. It's in the documentation, but the one that we have in the skeleton application module will work for 99% of you. You can just copy and paste it into every module you make, and it'll just work. The config listener, this is arguably the most complicated one, but also, in my opinion, the coolest one. All it's really doing initially is checking for a get config method in your module, and you are just returning an array from your get config method, or a traversable object. So you can use Zend config and load from an ini file or a YAML file. I typically just include that module.config.php and return the value from that. But that's all that the framework actually cares about, is what you return from get config needs to be an array or traversable. How you actually get that is entirely up to you. The init trigger, this one is just, if you need to do any kind of work the moment that your module is loaded, you can use the init trigger. You just define an init method. I would try to avoid this. This is kind of similar to how in Zend Framework 1 we had these _init methods that are always triggered. This is always triggered for every module, no matter what. If you do anything heavy or stupid in there, it could slow stuff down. So if you can avoid that method. If you absolutely need to, there are some rare occasions. You should try to only do lightweight things in the init method. And the reason for having this and not just using the constructor of your module class, for example, is if you need to use any of the classes that your actual module makes available in like the src directory, when the constructor is called, it hasn't called the getAutoLoaderConfig, so it doesn't know where your classes are yet. So it has to call getAutoLoaderConfig, set up the autoloading, then it calls your init method so that if you need to use any of your classes, you actually can use them in your init method. And the module manager itself is passed as a parameter to init, so you can actually use it if you need to. Check which modules have already been loaded, or manually load a module that's a dependency, whatever you need to do. The onBootstrap listener. This is just a convenience one. It checks for a method called onBootstrap, and if it exists, it's going to attach that as a listener to the Bootstrap event. So when later on, because modules loading happens first, then the application is bootstrapped. So later on when the application is bootstrapped, any code that you have in onBootstrap is going to be ran at that time. So this is kind of like a delayed action thing that you can have it run at the proper time. You could do this manually within your init method and attach your own onBootstrap. This is just a convenience thing to make it really easy for you to attach that method, since it's so common to do that. Location registration listener, I'm not going to really talk about it, but we have this thing called the service manager where all of your dependencies are registered, and that's how you actually define things like controllers and database adapters and view helpers. And if you implement this locator registration interface, or registered interface, that's what it says, it cuts off there, it will register your actual module class with the service listener. There was a use case for this a while back, but we've kind of solved the problem in a different way. So I'm sure a use case still exists, but it's not very common to use that. So the service listener. This one's pretty important. This is actually what where all of your different services or controllers or objects that are going to be used throughout your application are registered. It goes through either your config. So in your get config method, you can have in the array that it returns any of these keys. Within those keys, you have things like invocables, and I don't have enough time to really talk much about the service manager, but you basically can tell it how to create all of your objects that you need. So if you have a database mapper class or a database table class that fetches information, but it needs a database adapter, you can add that initialization logic there. So, okay, when I create a new instance of this, you need to pass it a database adapter to the constructor. Instead of like having that all in your, the wrong places, like the controllers and stuff like that, you shouldn't be initializing objects there. So we actually have separate service managers, these containers. You can think of them as kind of like registries, but they're not terrible like registries are. We have different ones. So we have the services one. That's the main one that your application uses for, you can use for anything in your application. Usually it's service classes or database mapper classes, things like that. Then we have a special one just for controllers. And that is because you do not want people to be able to manipulate the URL to pull anything out of this main service manager. So basically by having a dedicated controllers one, we have a whitelist that says these are the classes that are actually allowed to be invoked by a request from the browser. And then controller plugins and view helpers. They're pretty similar to how they were in Zend Framework 1, except now they're also using the service manager. So all of these different things, controllers, controller plugins, view helpers, have the same concept for loading them. So you learn the service manager once, and then all of these concepts will make perfect sense to you. And you can also have these methods in your module class that return also the same array that you would have underneath each of these keys. The difference is configuration is cached in production. So it doesn't loop through your modules and load the configuration for each one of them for every single request. It does it once, caches it, and just uses that cache file. You can define closures that actually instantiate your objects, and those need to go in here. So if you are using that feature of the service manager when you're defining a closure that constructs a new object and passes the database adapter in, you can't serialize and cache a closure. It doesn't work. So that's why we have these methods, are just for if you need closures in that configuration. Otherwise, if it's just scalar objects in the array, use the config keys, and it will be cached, and you won't have to worry about it. And then finally, the load modules.post is just an event for you to be able to attach to that you can be confident at that point that all modules have been loaded. And the init method, you don't know if your module is the third one or the fifth one or in what order it's been loaded. By the time this is fired, every single module has been loaded, and you can be confident of that. So module configuration. This gets kind of complicated. I've oversimplified it into 3 steps, but this is probably one of the most important things to really understand in Zend Framework 2 about how configuration works. So the first thing it does is it's looping through all your modules and calling the get config methods. And it's actually merging them together into one big array. So anytime you're defining configuration in arrays, think of it as one big array, one global array that you're dealing with. So if you define one key in one module and then you define that same key in another module and they both have string values, the second module that loads is going to win. That value is actually going to be what takes precedence. Earlier I showed the directory structure. There was an autoload directory that had a global and a local.php file in them. So it'll actually go through those and autoload all the files that match global or local.php. That pattern is in that application config that I showed earlier, and you can customize it. But that just gives you a place where you can drop in configuration files that might be like defaults for modules that you find online. They might have a dist configuration, a distribution configuration file. You can just drop it in the autoload directory, and that'll also be merged into the main configuration. Those are loaded after all the get configs. So any keys that are defined in these are going to override anything that was in the get config methods of your modules. And in our default pattern, there's anything that matches .global.php or .local.php is loaded. The local ones win over the global ones. So anything that's in a local file, config file will win. It's just merged last. So finally, the get service config, get view helper config, all of those methods, those actually happen after configuration caching and all that stuff is taking place. So those are the last ones that are finally merged into the main configuration. And that's because steps 1 and 2 are cached. And once the cache is in place, those steps are completely skipped. It just goes straight to step 3 and only calls those methods. And so some module best practices. I was talking about keeping the init method light. And on Bootstrap as well, because that's also always fired, just keep them really lightweight. Usually the only good thing to do in those methods is attach to other events that might be fired. You shouldn't be doing anything with the database there or anything like that because you don't really know what's going on yet during the Bootstrap. That's just a convenience method. So modules should also be read-only. Don't perform writes within your modules. And try to do one thing with your module and do it well. Don't create this one godly module that does everything for your application. That's just not good design. Try to make these discrete modules that are really simple and accomplish the tasks that you need to do. And utilize a vendor prefix so for your module names, especially if you're going to open source them. And that just really helps the community in general. So. And that's about it. Thank you guys. If you have any questions, let me know.